Hello, everybody. Okay, today my talk will focus on the lunar construction. Here are the contents. After introducing my company, I'm going to talk about space activities in general. Then I'll focus on the moon and the Mars. Then at the end, I'll share with you the current topics. Obayashi Corporation is one of the largest construction companies in Japan, which is almost a little more than 130 years old. And we, of course, we make lots of monumental buildings and structures. For example, the Tokyo Skytree is the world's tallest self-standing tower, and also major stations and airports and many others. Also, we do business overseas, of course, including the Olympic Stadium and many others. And okay, I belong to the Obayashi Future Lab in the company, which covers the 5 subjects. Space is one of them. And we are looking for the long-term future businesses. And the key phrase is open innovation, which means we collaborate with many different industries, institutions, academias, and universities. Okay, we have envisioned the concept for space habitats. This is the lunar city, which was published in more than 30 years ago. I bet you some of you were unborn at that time. In this concept, 10,000 people live and 2,000 people visit. Here is another lunar city, which will be built in lava tube. Okay, this is a Mars settlement. By the way, honestly speaking, Mars is my favorite planet. Okay, this is a concept for space station, which will be built in L1, which is one of the Lagrange points. This is the famous space elevator concept, which made a fantastic reputation not only in Japan but also all over the world. Our space activities have three themes. Go to space, live in space, and use the space. Go to space includes space elevator, of course, and also we have several types of the rocket launches. We collaborate with several different ventures companies, which not only from the launches from the ground, not only from the ground, but also airborne and from the ocean. For the space elevator, we carried out several experiments and the research. One of them is the space environment exposure experiment using the new material to test the new material. We use the International Space Station Japanese module. Also, we are developing the vehicles for space elevator. We are making this small-scale model for the vehicles, and we participated in the competition called the Space Elevator Challenges, hosted by the Summer Association every year. Also, we are interested in the movement of the cable. And so we formulated the equation of motion like that, including the many different forces, and we carried out the numerical calculation. And so we found out the movement of the cable. Another interest is on the interaction of the space elevator with the space environments, which include the solar wind particles, ionosphere, lightning, and so on. Okay, the second theme, live in space, which might be the most relevant in today's talk because this relates to the moon. If you go and walk in the celestial bodies with a partial gravity, you have to dig and excavate the ground. So you have to have a grant of the civil engineering and also the architectural engineering. So that's the reason the construction companies come into this field. Okay. Also, the agriculture is one of the strengths of the construction companies because we make a plant factories. Robotic construction is another cutting edge technology, which is attracting the increased attention recently. Definitely, this technique will be utilized both on the Earth and in space. Well, we're gonna talk about material destruction later in details. Let's skip here. The third thing, use the space, means we use the data transmitted from the artificial satellites to automate the construction works at the actual construction sites on the Earth. Now, let's focus on the Moon and Mars. This is the list of our R&D subjects for the Moon. We are going into the detail. This is the list for Mars. One of the subjects for the structure is the lunar shelter, which is an expandable structure, which can be utilized as a garage for rovers, which is equipped with multi-purpose functions, for example, the passive heat control and the protection from the severe space environment. Another type of the structure we are interested in is the inflatable one. If you cover the inflatable structure with a regolith, we can protect the people and the devices from radiation, micrometeorites, or temperature changes. We have carried out the inflation experiments to find out the multi-torus shape is the most stable inflatable structure. And another subject is manufacturing the construction material. Okay, the key phrase is local manufacturing for local use, because we cannot use lots of material from the Earth to the Moon because of the expensive transportation costs. So we have to use as much the local material as possible. All right. And so we apply the microwave to the lunar soil simulant to produce the sintered product. Another candidate for the construction way is to use the 3D printers. This picture shows just a demonstration on the Earth using the cement. However, this similar technique definitely be used on the Moon too. This is one example of the robotic construction. Actually, this is the autonomous system developed by our company, applied to the actual site. This is another example of the remote control operation of the machines. This is a case with using haptic technology to manipulate construction machine. So we transmit the information about the finger movements to move the machines. All these techniques of the robotic construction will be essential for the construction of the Moon. On the agriculture side, we made a special soil from microorganisms and the lunar simulant porous material to successfully grow edible plants. Actually, I ate the leaves, and I had no problem with my health, of course. But before going to the Moon, you have to have the simulated facility of the lunar base on the Earth. More than 30 years ago, we made a proposal, Moon Park concept, which is a facility for research, training, and education. Okay. We work not only for the moon, but also for Mars. Starting from the Martian simulants, which uh, consists of the igneous rock, clay mineral, and water, and we demonstrated to manufacture a Martian block, which is shown on the right side. We also work on the construction works of the initial Mars base based on the civil engineering works, which are excavation, leveling, and pipe laying. Okay, now let's move on to the current topics. Since 2021, the Japanese government launched the new research fund program called the Stardust program. So our company received the research funds in terms of construction, energy, and agriculture. So now we are running a research program on different subjects. Here are some of the results. Again, for construction material, at this time we applied microwave and laser heating to the regolith, and we assumed we can apply these materials as the pavement materials for the transportation road and the takeoff landing area, and also can be used as the protection material of the residential facilities. Well, again, we successfully demonstrated the sintering process both in air and vacuum environments, and we found that the strengths of the products are strong enough for the application. We did the similar experiments using the laser heating, and we applied the two methods to two different type of methods. And again, we found that the products has a good strength. For the energy side, we focused on the solar power generation in the polar regions. Our recommendation, according to our recommendation, power type solar power generator is favorable because in the polar region, the sunlight comes in the horizontal direction, and so we have to receive the sunlight in the sideway. And the single axis or polyhedral shaped system is advantageous for sun tracking, which is shown in the right-hand side. And also the operation, the activities should be limited only to the sunshine periods for the sake of economy and efficiency. Also, the tower should be more than 10 meters high to get enough sunlight. And also the structure should be expandable. And so we can get solar energy in 80% of the time. Based on these results, we created one 6-side breadboard model of expandable lunar tower. So eventually, we hope we can go to the moon to construct this kind of structure on the surface. Okay, at the end, I like to show my appreciation to the partners of the joint research. My work has been supported by many people and organizations. Okay, it's been it's been a pleasure to being with you, all of you, and if the audience are interested in our research and we can exchange the information and maybe the collaboration is possible, and so contact me. Okay, thank you very much for your attention.